We're on lesson 2 of chapter 10, which we're going to focus on experimental probability. First, we're going to solve a real-world problem with sports. Then we'll solve a real-world problem with weather. Let's just say, for instance, that I just found 4 tan rats and 2 dark brown rats in my basement. Thankfully, this is not a real situation. But let's just say it was. And let's say I was wondering what the probability the next rat I would find would be a dark brown rat. Well, we could use experimental probability. Experimental probability takes what you've already known based on experiments or data you've collected and turning it into probability for the next one. So the formula is the probability, or experimental probability, is the number of times the event occurs over the total number of trials. So in this case, the number of events that occur, the number of brown rats that I see, are 2 over the total number of trials, or the total number of rats, which is 6. If I simplify that, so 1 out of 3, I could determine that there's a 1 out of 3 chance that the next rat I find will be a dark brown rat. Let's try this with a sports problem. It says Tanya made saves on 15 out of 25 shots. What is the experimental probability that she will make a save on the next shot? Write your answer as a fraction, as a decimal, and as a percent. So if we got to go back to our formula, it's the total number of time the event occurs, the one that you want, over the total number of trials. So we're looking for the probability that she will make a save. So she saved 15 out of the total number of 25. We'll need to simplify this. We'll divide both by 5. That would give us 3 out of 5. So this is the fraction. If I do 3 divided by 5 on my calculator, that comes out to 0.6. Then if I'm going to turn that into a percent, 0.6, and move that decimal over, then that would be a 60% chance she would make that save as well. So these are my 3 answers to show the experimental probability of making a save on her next shot. Now we can solve a real-world problem with the weather. It says for the past 3 weeks, Carl has been recording the daily high temperatures for a science project. His results are shown below. So he's got 3 weeks worth of weather data. It says what is the experimental probability that the temperature will be above 75 degrees on the next day? So this is the event we are looking for. Remember, this is the total number of time the event occurs over the total number of trials, or the total number of times that it was measured. Well, I can figure out the total number of trials because it's 3 full weeks, so the bottom number would be 21. That's how many days were measured. Well, how many days were above 75? I have 1, 2, 3, 4, 5. 75 is not above 75. 6, 7, 8, 9, 10, 11, 12, 13, 14. So that gives me 14 out of 21. So my experimental probability is 14 out of 21, or simplified, divide them both by 7, 2/3. Now it's asking me the complete opposite. What's the probability that it will not be above 75%? And here's where we can use that complement. This is what we learned in our last lesson. The probability of an event plus the probability of its complement equals 100%, or 1. So the event happening was 2/3. The event of it happening, let's find it out. So writing that formula up here, the probability of 2/3, which is the high temperature, plus the probability of the complement equals 1. Then we could find the complement by subtracting 2/3 to get the complement by itself. 1 minus 2/3 equals 1/3. So the probability of the complement equals 1/3. So it would be a 1/3 chance that it would not be above 75% on the next day. And you can always check your work to make sure that the event plus the complement equals 1. 2/3 plus 1/3 would equal 1.